This is my report, The Necessity of Funding Stem Cell Research. For my abstract, the necessity of funding stem cell research comes from the past, current, and future projections of what these findings can be applied to. Two of the biggest roadblocks in this field of science have been the lack of funding and, until 2009, a lack of understanding that led to a restriction in progression. Stem cell research is one of the most versatile and groundbreaking avenues of science that has the possibility to cure a wide range of ailments, from spinal cord injuries to complete organ replacement without possibility of rejection. With all of the projected beneficial outcomes of this research, the necessity of focusing efforts into already established but underfunded divisions becomes paramount. By defining and then showing what the benefits this breakthrough branch of science has to offer, and contrasting that with the expenditures in the national budget, this paper hopes to move the interest in research forward towards an equilibrium that satisfies all parties involved. With the prevalence of ever-changing viruses, treatment-defying cancers, and other maladies that can affect humanity, science is struggling to find a panacea that can placate the necessity of dealing with added adaptability. A closer look at stem cell research shows that we are on the precipice of a multitude of breakthroughs that would allow us to address a myriad of issues, facing not only the American public but all persons across the world. Sadly, out of the $3.5 trillion federally allocated for spending in 2013, reference Fauci, Fraser, Jett, less than 1/25 of the percent went towards stem cell research. Reference National Institutes of Health stem cell research funding. In just the case of cancer alone, with 14 million people affected and 8.2 million dead in 2012, reference cancer, that is less than $65 per person towards the betterment of their health. Given such horrendous numbers, the outlook for the ultimate fate of mankind seems grim. Add to that the ban of 2001 to 2009 that restricted federal budgeting for stem cell research, and science has a long way to go to catch up. However, with stricter guidelines for the federal budget and tighter rein on superfluous spending, a proper redistribution of funding would be a step in the right direction towards putting stem cell research back on the fast track to restoration. What exactly are stem cells? The National Institutes of Health website gives a brief summary of them as such. Stem cells have the remarkable potential to develop into many different cell types in the body during early life and growth. In addition, in many tissues, they serve as a sort of internal repair system, dividing essentially without limit to replenish other cells as long as the other person or animal is still alive. When a stem cell divides, each new cell has the potential either to remain a stem cell or become another type of cell with a more specialized function, such as muscle cell, red blood cell, or brain cell. Reference Stem Cell Basics Introduction. Through three examples of the applications of stem cells, this report will shed light onto a minute fraction of what this field of science is and can be capable of. Alongside that will be data containing 100 examples of frivolous government spending and urging to rework the allotted budget. The following findings are based off of information analyzed from research released by specialists in official articles. After defining stem cells, this report continues on to examine the current and possible applications of stem cells, as well as the excessive spending of the federal budget. In my data section, we start off with stem cell familiarization. In order to understand the benefits of stem cell research and understanding what they are and how they work are tantamount with stem cell definition. Stem cells are cells in the body that have the ability to self-replicate for indefinite periods, often for the life of the cell. Given the right instructions, stem cells can differentiate into any multitude of cell types that make up an organism. These cells have the ability to develop into mature cells that have specialized functions, such as muscle, skin, or nerve cells. Embryonic stem cells, or the most commonly talked about stem cell, get their name based on their origin during the blastocyte stage of development prior to implantations in the uterine lining during in vitro fertilization. Considered pluripotent, embryonic stem cells have the ability to differentiate cell types from all three primary germ layers of the embryonic germ layers: endoderm, mesoderm, ectoderm, reference to stem cell. The ability to reproduce any cell in the human body makes embryonic stem cells the most versatile between unipotent and pluripotent. Cultivation simply requires a fertilized egg prior to in vitro fertilization to be harvested during the cell's blastocystic stage. Because there has been a lack of reference and refining on the process, there is a chance that a tumor may form due to the stem cells not knowing when to cease their differentiation. Adult stem cells, also referred to as unipotent cells, adult stem cells are distinct in that they are an undifferentiated cell within differentiated tissue. This means that they can replicate themselves and become the specialized cell of the tissue of origin. While capable of self-renewal for the lifetime of the organism, there are no isolated adult stem cells that can differentiate into all of the different cells of the body. This means there is no cure-all unipotent cell that is capable of adapting that is capable of adapting to the over 200 cells requisite of the human body. Due to the lack of transdifferentiating unipotent cells and the necessity of specific lineage, producing the amount necessary for therapy is a challenge. The practical applications of stem cell research. Though foreseeably a cure-all, stem cell research remains stunted in its infancy. Below are 3 possible cures currently being pursued in the medical community. Diabetes, cure 1. Affecting 29.1 million people in the United States and being the 7th leading cause of death in 2012, diabetes is a prevalent issue that needs to be addressed. In patients with type 1 diabetes, the cells that normally produce insulin are attacked by the body's immune system. In type 2 diabetes, the patient also presents with an insulin resistance, making the already lowered production of insulin insufficient in overcoming the necessity of the body. With an annual cost of $245 billion to the government, reference Santos Longhurst, therapies could greatly reduce the healthcare payments by preventing the side effects of diabetes, such as cardiovascular disease, amputations, and damage to kidneys. By being able to direct the differentiation of embryonic stem cells into insulin-producing cells, it would be possible to increase the effectiveness of transplantation therapy and even reverse diabetes altogether. Reference stem cells. Cure 2. Tissue donor and organ transplants. Organ and tissue donation is another prime example of the necessity of stem cell research. With demand far exceeding supply, an average of 20 people die per day while waiting for a donor that never comes. Amalgamated with the fact that every 10 minutes, someone is added to the National Organ and Tissue Donor Waiting List, reference The Need is Real, there is a compounded pressure for the medical community to provide. In order for scientists to be able to meet demand, they need to be able to refine a process that will allow them to produce a sufficient amount of stem cells that they can differentiate into the desired cell type, ensure that after transplant the organ and tissue survive and integrate itself harmlessly into the recipient, and function properly for the life of the recipient. References, what are the potential uses? With significant obstacles still in the way of this therapy, the medical community needs a financial boost to spur the possibility of successful output. Cure 3. Cancer. With over 100 different types and no established cure-all, cancer remains one of the deadliest blights. Ranked as the 2nd leading cause of death in Americans, reference Chan, this tumorous malady holds high priority for stem cell research. With the combination of chemotherapy and radiation treatments, the human body is assaulted with chemicals and radiation to try and mitigate or destroy cancerous tumors. Because chemicals and radiation are such strong therapies to begin with, the resulting collateral damage on the body includes destruction of healthy cells that are necessary to recover from the treatments. By increasing funding and research into stem cells, the possibility of expediting proliferation of healthy cells remains a possible outcome. Another avenue of treatment comes in the study of the cancerous stem cells themselves. By being able to analyze the genes in a patient's cancerous stem cells, scientists may be able to target and destroy tumors before they can metastasize, greatly reducing or eliminating the possibility of a recurrence. Reference treatment options with stem cells. A look at superfluous and misappropriated government spending. With the potential and inevitable benefits of stem cell research, the imperative of proper funding is ostensible. Given proper funding, the National Institutes of Health would slingshot our understanding and utilization of stem cells to catch humanity up from the ban of federally regulated funds appropriated towards this research. Senator Tom Coburn says in his book, Waste Book, Congress's role is not just passing bills. It is also responsible for conducting oversight to hold the executive branch accountable, which it is failing to do. In fact, Congress actually forced federal agencies to waste billions of dollars for purely parochial political purposes. Much like Congress, thousands of federal employees who weren't doing their jobs properly have been sent home and paid to do nothing, many for years. In his book, Senator Tom Coburn compiles a list of 100 of the most ludicrous expenditures and endeavors of the United States government. While it is important to maintain a well-funded military, steps must be taken to prevent overspending. In 2013, the United States government spent $1 billion to destroy $16 billion in surplus ammunition, while, according to the Government Accountability Office, some of the materials set for destruction had been found useful. Reference page 44 of Waste Book. Another overshoot of military spending is the scrapping of $468 million worth of airplanes slated to be the backbone of the Afghan Air Force air transport mission. Reference page 64 of Waste Book. The planes were scrapped for a total improvement of $32,000, a move that was attributed to a poorly managed program. Looking past the military spending, there are plenty of other avenues that required an exorbitant amount of money. From renting out the Jonas Brothers' house to ensuring that Disney's Polynesian Resort gets a makeover, a multitude of red flags have arisen. These are programs funded by the American people's taxes that happen to be very beneficial to a select number of people. With closer regulations on who is spending what, and ensuring that frivolous charges are kept to a minimum, Coburn assesses that there would be a savings of $25 billion that could be used for more beneficial endeavors. Reference page 7, Wastebook. In conclusion, my summary of findings. My findings during an analysis of information shows that through the positive funding of stem cell research, the plateau of human science and advancement has an incredibly bright future. In a world where superfluous spending is cut and redistributed into the necessary institutions, there may be no upper limit of what diseases or injuries humanity will be capable of triumphing over. The interpretation of my findings. The interpretations of my findings show that the possibility of stem cells adapting and being utilized in a multitude of situations allows them to be the panacea that the medical community has been in search of. With the prospect of an additional $25 billion available for research and the lift of the ban of federal funding towards stem cells, the government has much to make up for in its retardation of scientific progression and need to reprioritize its expenditures. Recommendations. My recommendations, based upon my findings, are a necessity for the prompt redistribution of government funding through stricter budget enforcement and an emphasis by the National Health Institutes to allocate a larger portion of its yearly allotment into stem cell research. My references are available below.